Artificial intelligence has the potential to change the way we practice medicine and public health. The tools that AI provide can substantially impact a broad range of fields, from the manner we approach patient care to strategies to discover new antimicrobials, track pandemics, and deploy public health measures. AAC recently published a commentary on the impact of artificial intelligence in infectious diseases, and we will have a conversation with the lead author of the manuscript and an expert guest who are applying these concepts in real time. Welcome to Editors in Conversation. The objectives of this podcast is to understand basic concepts of AI and different applications, discuss how AI affect the practice of infectious diseases and antimicrobial research and therapy, and elaborate on a specific example in which AI may have a transformative effect on the future. This episode is brought to you by the Antimicrobials, Agents, and Chemotherapy Journal, available at asm.org/AAC. I'm your host, Cesar Arias, Editor-in-Chief of AAC, and this podcast is supported by the American Society for Microbiology, which publishes AAC. If you plan to publish in one of our journals, particularly in AAC, which is a leading journal in the field, ASM members get up to 50% of publishing fees. So visit asm.org/membership to sign up. Don't forget to check our latest issue of AAC at asm.org/AAC with outstanding papers on mechanism of resistance, pharmacology of antimicrobial agents, epidemiology, and clinical therapeutics, among others. We also have a new collection in our website with all papers published in the section of New Perspective Antimicrobial Agents, and we did a podcast last time with our new section of Antimicrobial Stewardship. Joining us to discuss this important topic, really very important person here, important people, Dr. Lilian Abbo, who is Associate CMO of Infectious Diseases and Professor of Clinical Infectious Diseases at Jackson Health System at University of Miami Miller School of Medicine and the Miami Transplant Institute, and she is the lead author of the paper I mentioned. And Dr. Masayuki Nigo, who is Associate Professor of Clinical Medicine at Houston Methodist Hospital and the section of Transplant Infectious Diseases. Welcome to the program, ladies and gentlemen.
Thank you.
Thank you, sir.
So AI is in fashion, right? Everyone is talking about AI, but our audience may not know exactly what AI. So, Dr. Abbo, let's start. What is AI?
Well, AI or artificial intelligence it's really the simulation, and to me the term is misused because it should really be augmented intelligence, not just artificial. It's really augmented intelligence of humans and using that in computers and other machines. And it really is creating systems that can help you perform the task that you require human intelligence, but simplifying your work. For example, understanding natural language, recognizing patterns, solving problems, or making decisions. So even though it sounds very fancy, we all use AI in our daily lives. If you are binging in Netflix and watching movies and you think that Netflix is recommending the next movie based on the color of your eyes, it's actually Netflix recognizing patterns in your data, which are the movies that you've seen before, and they're using AI to prompt you to binge on the next one. So within AI, there are different types, right? There's a whole portfolio, and we have machine learning. Part of it is natural language processing, and we also have deep learning, which are our neural networks. And that really works with algorithms that it's going to use data and improve their performance over time.
So that's a great explanation. So people are very afraid of this for several reasons, particularly replacing humans. So Dr. Nigo, so what are the different classes? Dr. Abbo just mentioned about what is deep learning, what is machine learning, how this concept come, and what is there a real sort of problematic that they are going to replace humans, the machines, Terminator?
So thank you, Cesar. So the machine learning is kind of a subset of the AI that's kind of focusing on creating algorithms, and then also some are, relying on the statistical models to allow the computer to perform the task, like, based on the patterns and then also the inferences. So for example, like, under the machine learning models, like we use like logistic regressions, or sometimes like the random forest. And then that way, those like the multiple methods to kind of conduct analysis and then try to, understand. And then as Dr. Abbo said, the deep learning is even like a smaller subset of the machine learning. And that uses a neural network. The neural network is, between the input layers to the output layer, they have multiple layers between them. And then they have like, that's why they call the deep learning. And then probably, you have been seen some scheme of the deep learning, which has like the multiple nodes, and then that's connected to each other. And then they understand the complex, the relationship between them from the input to output, and then try to understand the background of the data, and then to provide more detailed information. So for example, like current language models, for example, like a ChatGPT, they use these deep learning models to provide this kind of the predictions or text data, or even like creating images.
So I want to add to that, to make it like simplifying to the audience who's not like tech savvy, right? When we talk about these neural networks, it sounds like a very abstract concept because they're going in layers, and these layers are running data in parallel. So for example, you're looking at a CAT scan, and that CAT scan, you're ruling out tuberculosis, and you're looking at the images. There is one neural network that is looking at these images while in parallel is processing the language that the radiologist is reading to determine what is the probability of this patient having tuberculosis based on the findings and based on the images. So you're running multiple layers of data simultaneously and a very quick velocity, probably faster than a human being. And the computer is learning and learning as you expose them to that. So you minimize the level of error.
And this is why people become a little bit uneasy with this, and how the decision-making process is when you learn based on what you input, right? But Dr. Abbo, you did this beautiful commentary, and you started explaining about the landscape of infectious diseases, which is the topic of our discussion, and how this AI can sort of influence this landscape. Can you elaborate a little bit what you meant in this paper?
So I think the landscape, we're just seeing the tip of the iceberg. And if you know, when you see a tip of the iceberg, 90% of the iceberg is underneath. So we're just scratching the surface. Healthcare, as usual, we're late adopters of technology. In other areas of your life, we have all been using artificial intelligence. When you're using Siri, you're using artificial intelligence. When you are actually using any type of Word document or Grammarly that is correcting your grammar, you're using artificial intelligence. So imagine what we can do in infectious diseases and precision medicine. So if you look at the world of ID, we just went through the largest pandemic in the history of the world, right? And the technology is able us to connect, to make rapid diagnostics, to do contact tracing, and to develop new drugs, new agents, and new vaccine in no time. So with the use and the advances of these artificial intelligence and these learnings, we can actually reduce the burnout of our providers, because we spend a lot of time documenting and doing a lot of work that perhaps is repetitive and perhaps a machine can do and help us train. We also, for those of you who are clinician scientists, when you do clinical trials, you know that enrolling patients and selecting the patient criteria for a clinical trial sometimes leave out a large percent of the population to which this drug will actually be used. There are some inherent selection biases. With the use of the new AI techniques, we're going to be able to really identify quickly who's the patient population that will benefit the most, and perhaps implement rapid drug development. So when I talk in the paper about precision ID, is really a novel concept. It's really using precision medicine and infectious diseases. It's personalizing not just the prevention and the diagnosis and the treatment, but it's also incorporating. Imagine that instead of just seeing the patient and having to get a medical history and ordering all these tests, you could already have the genomics information of the patient, the whole genome sequencing of the bacterial infection that's causing, determining if this patient is going to respond to this drug better than others based on the genomic information, and also understand the patient environment and their social determinants of health. So you're really doing holistic care rather than the fragmented care that we have right now. And this applies to developed countries and developing countries, in which we know that the disparities in healthcare are even bigger. So if well applied, all these novel, precision healthcare and precision infectious diseases can really be a paradigm shift in the way we practice ID from prevention to treatment.
This is a fantastic explanation that you just made on this. And that concept of precision medicine that is being pushed by NIH for a few years now, usually dedicated to chronic diseases and the genetic background. I'm fascinated now how we can incorporate now the genetic background of the infective organism, because at the end of the day, an infectious disease is the interaction between a pathogen and a host. Dr. Nego, you are, as Dr. Abbo are, a transplant infectious disease specialist. And how do you see this AI, and particularly these terms that we are hearing right now, like cognitive versus generative artificial intelligence, and that makes you think that now the computers are thinking more and getting to this point in making decisions?
Right. No, I think it's it's important to differentiate those terms in AI. Continues to evolve. The generative AI is like kind of refers to the model that's capable kind of producing like some content based on the patterns. Like, for example, like, based on the big data. So, for example, like, the chat GPT and so on, they learned, or they use the, huge language models, and then they are creating like a text or sometimes like the images, and so on. But on the other hand, the cognitive AI, as you just alluded, it's more like a, mirror the human thought process, or kind of like the decision making. It's, the understanding and the reasoning, and then also, from the big data set as well. So, for example, like, one of the example going to be like, for example, DeepMind, AlphaGo. That's one of the, the famous or popular board game in like Asian countries. And then they are reinforcing, like the first time they may not be able to do well, but after learning or, playing together with the humans and then learning more and more, and then reinforcing, and then they are, finally beat the humans. So I think those are the, the two, important concepts.
And there is this, there is a famous chess game with the world champion that was defeated by an AI-driven computer, which is kind of scary, right? But moving away from the scary part, I think this is just we are in a moment of real expansion in this field, and I believe it has so many good applications, and this is going to be a tool. So one of the things that you talk about, Lilian, in your paper also is this concept of a smart health and what we call the Internet of Things. Mm-hmm. Actually, my hospital where I work for is just building a new hospital opening in 2025, completely powered by AI, opening in 2025, where just with maybe on iris recognition, everything is going to be known about the patient. So tell us about the concept of a smart health.
So, well, this concept of smart health, like you alluded, really is using the Internet of Things, because we already live in a world that is truly interconnected, right? So people are very, familiarized right now with telehealth, right? With the pandemic, telehealth became sort of, we broke the barriers to adoption, and people feel very easy, using telehealth. But now, imagine that you can combine the heart rate that you're monitoring in your Apple Watch, right, with this telehealth visit. So in real time, you can look at your patient's vital signs. You're not just having two devices that are completely disconnected from each other, but now you can do remote patient monitoring, and you can actually look with wearables and with other devices what's happening at the patient. Now, the way this technology is moving is like a light speed, right? Back to the Future is like really outdated compared to what's coming. There's now technologies that are looking at things that are not even wearables. They're called the invisibles. So, for example, the same way that you have a Wi-Fi box in your house, you might be able to put one of these Wi-Fi boxes or invisibles in a patient home, right? And you might be able to monitor how the patient after hospital discharge is doing with their COPD, their antibiotic compliance. You may be able to assess mobility, because these sensors are going to be able to tell you, hey, this patient is falling, and you're only managing perhaps the ID part, which is the infection and the acute bronchitis, but this patient might need to be reassessed because of balance. They may have neurologic issues. So it's really putting into context, a smarter health. Rather than managing one disease, You're really holistically caring for things, and you're interconnecting everything. Now, like everything, and we can talk a little bit more about it, there are pros and cons about this, and it all comes down to how we apply the technology. Because like everything we know, if you do it well, it can help a lot of people. But if deployed with bad intentions or unconscious biases, we can actually cause potential harm. You may not want the pizza guy delivering your pizza to have all your information and to know that you have a levofloxacin resistant E. coli, right?
Yeah. And we will talk about that, in a minute. What are the caveats of all this excitement? Because there's always caveat. But I want to bring the conversation down to our field, more specific field, in particularly microbiology and infectious diseases. And one of the things that we're using more and more, of course, is whole genome sequencing and how to interpret it for susceptibility testing, for example. So, Dr. Nigo, can AI help us in this regard too? And would the clinical microbiologist's job be in jeopardy if a machine eventually can interpret all of this data?
Right. I think the AI models or computers, the best thing is, they are able to take any kind of information, from the big, huge data sets, including like genetic data or even like, medical record data and so on. The machine doesn't understand that this is from the genetics or this is from the, the text or this is from the medical record. So basically, taking all those informations and then they are able to, digest as long as you have enough, data, and then they may be able to find which we may not be able to find because, it's very difficult for us to go through each individual genetic patterns, but they may be able to pick those patterns, more nicely and, accurately. Yes.
So what are your thoughts, Lily? What are your thoughts about that?
My thoughts is I think we're not going to be replaced by computers, but there are parts of our jobs that will be replaced by computers and will make our lives easier, right? So I'll give you an example. You go on a plane very often, right? Well, most of these planes are being, driven by pilots that have automation and computers. We have not seen pilots laid off, but most of the time they're not manually flying the plane. So where is in microbiology AI being used? We know that many laboratories have already done automation with image recognition. Right now, our lab is huge. Our microbiology techs have to go through plates and plates to try to determine if there's growth or no growth in the urine, right? Or in the blood. So imagine that now with these visuals, you have recognition and they tell you, hey, do not focus on these 50 ones that are normal and negative, or perhaps have very little growth and contamination. Focus on these 10 ones that are really abnormal. And based on the visual recognition, they can tell you which organism it is. Then if you add to that, like Dr. Nigo mentioned, the whole genome sequencing, you're very quickly able to not only identify the genetic patterns, but you're able to analyze this massive amount of data that in a human brain, it will take us days, weeks, or months to develop. So I do see tremendous potential, especially for new drug development and discoveries, because right now, if you can integrate this information and the machine can do it in a much more efficient way than a human, I don't think we're going to be replaced. I think we're going to be more efficient and more productive in the outputs that we generate with the research and the clinical work.
Yeah. This is the first segue for the next thing that I want to talk about is drug discovery, particularly antimicrobial drug discovery. And AI has been used now to the discovery. And last time I reviewed this, which was recently, there were about 10 drugs already in clinical trial that had actually been discovered with AI. So Masa, so in terms of discovery of new drugs and new antibiotics, how AI can help us accelerate this process instead of taking 20 years? Can we do it shorter?
So I think, as Dr. Abbo, just mentioned, I think the biggest part, for the AI can help is to try to pick like some of the potential, the drug, the candidates. I think, we cannot completely like eliminate, the human work, but the AI could help. What would be the potential, the substances, from the the millions or tons of, the substances which could be, potential, the candidates for the new drugs and so on. So I think, in that sense, I think, it can be, the helpful.
Yeah, and AI can recognize the structural information, run several simulations to target it specifically. For example, you have the crystal structure. In terms of monoclonal antibodies and vaccine development, this is an enormous potential. Lily, what are your thoughts? That you put several examples in your paper about it.
Yeah, and we actually talk a little bit about quantum computing too in that area, which we can talk a little more in detail later. I don't want to overwhelm the audience with new terms, right? But if you think of AI and these computers that we're using with AI are machines that are going millions of times faster than our traditional computers. What happens with the drug discovery is that with this massive, amount of data and computers, not only are you able to identify the molecules, but you're also able to virtually run these chemical reactions and look at interactions between drug molecules. So really that affects, the discovery much faster because you can look, for example, one example we give on the paper is digital twins, right? So a digital twin is like a digitalized human. And instead of giving the drug to a human to see, oh my God, you had adverse effects or drug interactions, you're actually testing that in a virtual environment. It's what they call in silico model rather than in vitro model. So to me, that's fascinating because instead of deploying a drug that, it takes 10 years by the time you develop a drug and you enter into the market and then discover that there were failures, you can predict those failures sooner. And then if you're going to fail fast, change it and modify it and do something that may work.
Yeah, very interesting, fascinating conversation. So Masa, you recently got a perfect score in an R01 in AH using this AI for pharmacokinetic analysis of vancomycin. So tell us how that works.
Thank you.
Without telling all of the details of the grant, of course.
Yeah, yes. So actually, this is one of my, research project. They're using the big data and then artificial intelligence, so that particularly like a deep learning, like a cognitive AI. It's like try to mimic like the human thinking or pharmacist thinking. So as you know, like currently, like the Bayesian model for, the vancomycin becoming more available in hospital. But however, this Bayesian model is really using like limited set of the data sets, such or information, such as like, demographics or patient creatinines and weights and, and then also the dosing of the vancomycin and levels. But, I think, those precision dosing, the, most need is for critical, ill patients, like in ICU patients. And then those patients have like, timely changing the pharmacokinetic parameters, including, getting, the fluid or the vital signs, and then also, the ECMOs and then so on. That will all changes significantly the pharmacokinetic parameters. So my project is try to incorporate multiple different, the patient features into a deep learning model to learn actual dynamics of the pharmacokinetics of the patient, and then try to predict, the more accurate and then more, close to, the precision dosing. So that's kind of my project. But I think the overall, what I wanted to say is, the important thing is, for example, like, the Bayesian model requires the vancomycin levels to kind of like predict the, the patient-specific factors. But we already have tons of patient-specific information in the medical record, even like before starting a vancomycin. So we try to kind of like, get those, patient history and then more detailed information. And then that's how we can like, apply to, not only the vancomycin, but other kind of the medications and the pharmacokinetics. So that's kind of my project.
Yeah. So basically, if you are successful, we could predict the doses of a patient of vancomycin without even having to take levels. And if they take levels, it will be even better. But AI will predict specifically what the dose according to the condition of the patient, which will be amazing. And that can give you for any kind of drug, right? So, the other thing that you mentioned in your paper, Lilian, was quantum computing, because I just want to talk about a little bit of this, And for the audience, that is not savvy, and I'm not by any means any savvy of this, but we use the binary system for our even more advanced computing. So, but this quantum computing takes this real concept that a particle could be at the same time in different parts, and using this sophisticated computing that sometimes need a lot of low temperatures to function, they can perform this task at amazing light speed velocities. So Lilian, so imagine having these machines available. What AI can do and how far can it go?
Well, so let me start by saying that I am not an expert in AI or quantum computing. So I'm also in baby steps learning, and again, this is going faster than we can learn. But I'm fascinated by this topic, right? So quantum computing, like you mentioned, it's really using the quantum theory, right? And you're using parallel processing. So as humans, we think we can multitask, but we know very well that we're not that great multitasking when we think we're doing it. So what this quantum computing is doing is really multitasking, and it's doing it in parallel in multiple systems at the same time. So for example, we spoke about drug discovery. Well, you can use simulation of molecules and how these molecules fold and how will they interact, with the other proteins, and how will the chemical reactions generate new drugs. Other applications in infectious diseases are genomic analysis, right? So you're going to take this very, very large genomics data sets. It could be human genomics or bacterial or viral or fungal genomics, right? And then you're going to be able to do more efficient sequencing, alignment, analysis. So that helps us to do more personalized medicine and antimicrobial resistance and drug development, or predicting who's going to develop antimicrobial resistance. So we are more, better antimicrobial stewardship. Clinical trials. So with the use of quantum computers, you can actually identify very quickly what are the optimal parameters that you will need in a clinical trial. And then you can speed up the process in the drug development, or let's say you're trying to develop a vaccine, that could help you as well. Medical imaging. So if you're able to look at more accurate image analysis, that will help us diagnose disease way faster. So imagine with the monkeypox outbreak, a lot of people were using image recognition, where you can look at the lesions and say, hey, this patient has monkeypox rather than something else. So if you can use that at very quick velocity, imagine this with more complex infections. And then healthcare optimization. And I think we all need to be cognizant that we all work in very complex health systems. And you're always wondering, how do we allocate resources? How do we schedule? How do we manage supply chain? You had a pandemic. How do you make sure that you don't run out of masks? And how do you run out of PPE? And really using quantum computing, you can also use in parallel different simulations and imagine different situations in order to allocate your resources more efficiently. So to me, this is super cool.
Yeah, I agree. Cool enough. Any comments, Masa, on this?
Yeah, right. I think, as you know, the medical record data has been exponentially exploding in the world. And then now we have those data exchange, also the identified database. So the amount of the data we use every day is getting bigger and bigger. So I think, not only algorithms and deep learnings and so on, I think that computationally, we have to have more powerful, the computers, so that way we are able to process and then train faster, those models, and then that I think will be, very fascinating and helpful.
I want to touch on something that Masa, maybe you can discuss in more detail. But we often talk about the medical record, and people think this is good. I mean, one of the reasons why machines cannot replace us as doctors is because the medical record is trying to read in Chinese while you're speaking in Arab. It's sometimes illegible. We have structured data mixed with unstructured data. So one thing is very simple. It's very simple to analyze temperatures at different times in a patient, which is very structured. We document it in the same way. Very different. Try to read a medical record where somebody's writing, patient has fever, pan culture. In another record, they're writing blood cultures ×2. In another, they're writing, we all have acronyms and we write different things differently. So to analyze that unstructured data and try to come up with predictions, it's much harder. So that's what the machines are really trying to learn, right? How to integrate this complex human brain with data that is unstructured, and how do we convert that into something more structured that then the algorithm can analyze? Because the algorithm doesn't know if monkeypox really means that you had a monkey with pox, or monkeypox means a viral infection.
Yeah, and now that it's called mpox, even more difficult, right?
Correct. So I'm just
and I dream to the time that we as infectious disease clinicians spend a lot of time behind a computer instead of spending that time in front of a patient. And I'm hoping that these advances will help the documentation of our encounters in a much better way, an efficient way, so we can spend more time for the people we really care about, which is our patients, right? Okay, the last part of the podcast, I want to talk about the problems of this, all of this. Apart from the fears that I mentioned at the beginning, that people think, oh, I'm going to create terminators and they're going to end up the humanity. There are very important AI companies that have actually warned about this. So I don't think they have some foundations of this. So let's talk about personal information first, privacy. So, Lilian, are you concerned about privacy issues with this, as you mentioned before, and how we can handle this to take advantage of the technology and not break privacy in patients?
So yes, I have concerns because we live in an interconnected world and we are living with a mix of generations, people who feel that they have to post everything in social media. And sometimes people don't realize how much they're sharing. Also, right now, where the way our medical record function is it's all or nothing. All your information is there. So if you share your electronic medical record with someone, they pretty much have all your information from insurance, blood work, radiology, progress notes, psychiatric history. So now imagine that Apple or any other company through your iPhone or Apple Watch are able to get a hold of all this information. So you have to really be very careful. And that's where blockchain and other technologies can help us, because perhaps you don't want to share all the information with everyone. And that will require literacy, patient education. What do you want to share? It's very different to share, I went on vacation to Hawaii, than to share that you have a genetic mutation and X, Y, and Z, right? So medical record and data privacy are on a different ballpark than any type of data that the commercial companies in the businesses we interact every day are. So I do think we will need ethics. It's a big part of this, compliance, patient literacy, and ensuring that the technology, it's safe and it's allowing you to decide that you as the patient own your data. You need to be the owner of this data, and you need to decide who to share it with and when.
So in regard to that, the other concern, and is very well said there, Masa, is cybersecurity, right? We know there are actors out there who are phishing and very tech savvy and that can get into any computer. So if your medical record, your health information is there, they will be able to get it. And I feel that the advancing in creating this technology is way advanced, and the measures to counteract attacks is lagging behind. So what are your thoughts on cybersecurity?
Right. That definitely, like, the cybersecurity is, one of the concern. Like, as you mentioned, I think the cybersecurities and then also the protection is always, they are competing each other. And I think, one of the technologies, like, for example, encryptions, and then try to, block those or hide those informations. But also, like, the advanced technologies of computers, and then they may be able to, break those, the encryption. So I think, definitely, when I taking care of those, the large big data sets, from the hospitals, I usually, try to make sure, those data should sit into the most protected, locations in the hospitals, and then, they're not to, leak any information.
Yeah. So any thoughts, Lilian, on cybersecurity?
Well, I think, like Masa mentioned it, I think it's really how do you deploy it? How do you, what measures are you going to put to make sure that you also have data integrity? Because if you really want to make sure that people trust the AI, they need to make sure that the data is protected, the data is secure, and that is a big problem. Because the AI models learn with data. The more data we share, the better the model gets, right? And these are massive amounts of data that this algorithm needs for training. So Netflix is not just taking your preferences for movies, they're taking millions of people, right? Millions of data points. Well, imagine that in antimicrobial resistance. If you really want to train the AI algorithm, you really need to educate that algorithm with data, right? So the more genome sequencing you share, the more refined your AI will be, making a prediction in telling you, I see this pattern, this may happen, right? I see this pattern, your patient may develop sepsis. So what you're trying to do with AI is predict. You're not trying to detect, you're trying to predict. So one of the challenges in healthcare is all the cybersecurity and privacy that we have, that sometimes our systems are not interoperable. How many of you have a health system or a hospital that has one electronic medical record, and now the radiology doesn't connect to the EMR, so you have to log off and log in somewhere else? Or if I bring, the images from another patient from another hospital, mission impossible, try to open. So I do think cybersecurity, privacy, and interoperability, new laws will have to be written, because otherwise it's going to be very difficult to share data. And one of the things is, you want to make sure that when you create an AI system or a prediction, I want to make sure that my prediction in Miami is going to work in Houston, and you want to make sure it works in Colombia or in Japan. You don't want to create a prediction that just works in your ecosystem. You want to make sure that there's interoperability so you can help millions of people with that prediction.
Yeah, beautiful. I'm going to finish in a high note here, and is one of the potentials I see of this technology is to help with health inequalities, particularly around the world. So access to healthcare through this Internet of Things, where people can access, experts, real experts, and you use drones to deploy specific medications that is being done with, for example, with blood products, and make a big difference. So let's start with you, Lilian. So what are your thoughts about that, and in an optimistic way as you are?
In a very optimistic way, I absolutely agree that this could help deliver really this concept of smart health and one health, right? And this has potential in infectious disease, in veterinary medicine, in human medicine, in neonatology. It's really breaking these disparities that exist. At the same time, you need to understand that the cost of implementing some of these technologies, it's high and it's coming down, right? And you do whole genome sequencing. You know how the cost of the reagents and the instruments are changing very quickly. So, my goal is that we eventually will be able to have point of care testing that at a very low cost, that you can deploy very quickly, and it connects with your phone or your watch, and you're able to very quickly send a direct prescription to the pharmacy, and you're going to be able to get your medication delivered on a drone and be able to take care of that patient. That requires literacy. And the same way this could be opening doors, it could shut doors for people who don't have access to that literacy. So as we deploy the technologies, we need to make sure that we incorporate them into all layers of society and globally.
Great. Dr. Nigo, I'm going to give you the final word.
Yes.
So what do you think about this?
Right. I think, I also wanted to see the, optimistic way, because I think, for example, like those trained models or ChatGPT, you may be able to use those, highly trained models into a, smartphone or some small devices. So, in order to kind of like making those programs needs to be done in large scale settings. But however, once it's trained and then create the models, then they may be able to deploy those, the countries, and then they may be able to use, the better. So I think hopefully, in the future, some AI project, can, solve those, disparities.
Well, I want to thank you for your time. I strongly recommend everybody to read this beautiful piece from Dr. Abbo and collaborators in AI, published in AAC. And I think the future is now, and there's a lot of things to look forward to. Thank you very much for your attention. This is Cesar Arias, Editor-in-Chief of AAC, signing off.